Hello everyone, welcome to the sessions on the advanced communication. This is the unit 3 satellite fundamentals. In this particular unit, it is the session 1. That is satellite fundamentals. The contents which we are going to cover in this particular session are satellite definition, types of satellite, satellite orbit shape, definitions. About this we are going to learn about in this particular session. Now what is a satellite? The definition for the satellite: an artificial body placed in orbit around the earth or moon or another planet in order to collect information or for communication. That is, satellite is nothing but it is an physical object here. Satellite is a physical object which revolves around some celestial body. The physical object which revolves around some celestial body, that is called as the satellite. In nature also we are having the satellite system here. For example, all the planets which are revolving around the sun, they are acting as a satellite here. Similarly, moon which is revolving around the earth, it is the satellite for the earth here. Therefore, those are the in nature natural satellites here. But the satellites which are launched by the human beings, those are called as the artificial satellites here. Now, therefore, for the definition of the satellite, it is a satellite is a physical object that orbits or revolves around some celestial body. Our own solar system is a perfect example. As I said, here it is the perfect example for the satellite system here. The Earth and other planets are satellites which revolve around the sun. Now, the satellite is a physical object that orbits or revolves around some celestial body. Again, the types of the satellite, which are the different types of the satellites are available. One is the active satellite and other is the passive satellite. That is, active satellite means what? Here, in case of the active satellite, the satellite will receive the signal from the Earth station. It will receive the signal from the, suppose here the satellite is present here means, suppose this is the satellite means here, it is receiving signal from the Earth station here. And it will modify the signal here. For example, if it is the F1 is the frequency which we have uploaded from the Earth station to the satellite means, here it will transmit it as F2. It will changes the frequency as well as it will amplifies. It will changes the frequency as well as it will amplifies. Then that is called as the active satellite here. Then that is called as the active satellite. Now for the passive satellite, if the passive satellite, if you consider here, if it is a satellite here again, the signals which are radiated from the Earth station, for example, it is F1 means it won't changes anything here. Just it will receive and it will re-radiates back the signal as a F1 only. Then that type of satellites are called as the passive satellites here. Those are called as the passive satellites. That is, the active satellite means what? The satellites which are receiving the signal from the Earth station and modifying them. They are giving the amplification as well as the particular change in the frequency. Then those are called as the active satellites. And if the satellites are receiving the signal and sending as it is, then those are called as the passive satellites. Now the satellite orbit shape here. The orbit means what? As the satellite is rotating, it will take some path there. As the satellite is rotating, suppose here the Earth is there. Suppose the satellites are rotating here, correct? Around the Earth means they are taking some path here. This particular path is called as the orbit. This particular path is called as the orbit. Now we are having a different shapes in the particular satellite here. Here the equatorial orbit and the equatorial elliptical. Equatorial circular and the equatorial elliptical. Next the polar circular and the polar elliptical, and the inclined circular and the inclined elliptical here. These are the different shapes of the orbits here. Now see here, this is the equatorial here. That is the plane is the equatorial plane here. Now it is the circle. If it is in the form of circle means that is the circular, and if it is in the form of ellipse means that is the elliptical. Similarly, this is the polar orbit here, like vertical. This is called as the polar orbit, and if it is the circular means it is the circular polar, and if it is the ellipse means polar elliptical orbit. Similarly, inclined, it is not fully vertical or not fully horizontal. It is having some angle of inclination here. It is called as the inclined orbit. Again, in the inclined, if it is the circular shape means the inclined circular. If it is the elliptical means inclined elliptical here. These are the different orbit shapes here. Now, as I said, satellite orbit is the path in which the satellite revolves around the Earth here. A satellite stays in the orbit because the gravitational pull of Earth is balanced by the inertia of the revolving satellite. Because those satellites are launched using the rockets, and the means rocket is providing the forward as well as the vertical motion to the satellite here. To launch the satellites, rockets are used. When the satellite will be in the forward motion and in the revolution, it is generating some inertia there. Now there exists the balance between this gravitational pull and the inertia, which will maintain the satellites in the correct orbit there. Now the satellites are launched by the orbits by the rockets, as I said, vertical as well as the forward motion here. It is providing the vertical as well as the forward motion. If the satellite is closer to Earth, the gravitational pull is stronger. Therefore, they should move with very fast velocity, very high speed they should move, because inertia should be high such that to overcome that gravitational pull, strong gravitational pull there. In low orbit, satellite must travel faster to overcome the gravitational pull. Now these are the satellite orbit shapes here. This is the polar, and this is the equatorial, and this is the low Earth orbit here, and it's the geostationary. We will study that one later. What is the geostationary orbit? Now again, these are the some of the pictures which shows the satellite orbits here. Correct? These are the some of the pictures here. Now, some of the definitions related to the satellite here. First one is the Posigrade orbit. Posigrade orbit. What is the Posigrade orbit? If the direction of the satellite's revolution is same as that of the Earth rotation, as we know, Earth is also rotating on its own axis. If that direction and the satellite's rotation direction is same, then that type of orbit is called the Posigrade orbit here. Similarly, if the satellite's revolution is against that of the Earth's rotation, if it is against that of the Earth rotation, if it is rotating opposite to the Earth rotation, then that is called as the retrograde orbit here. Now this is the geocenter here, center of the Earth, and from a height above that, this is the line drawn from the satellite to the center here. Correct? Now this represents the height of the satellite here. At what height the satellite is rotating. Now the sub-satellite point. Sub-satellite point is nothing but the point directly down from the satellite here. That is point where straight line drawn from the satellite to the center of the Earth intersect the Earth's surface. That is called as the sub-satellite point here. Now again these are the different, this one apogee and the perigee. Apogee means what? The highest distance between the center of the Earth and the satellite is called as the apogee, and the perigee is the lowest distance between the Earth and the particular satellite. It is called as the perigee here. For example, if you consider this is the Earth here, correct? If the satellite is rotating in the elliptical fashion like this, in the elliptical, if it is rotating means what will happen? Suppose this is the Earth means, and here it is rotating in the elliptical fashion here. Suppose it is rotating in the elliptical fashion means, if you consider this point here, this point, it is the distance from the Earth to the, this point is long here. If you take this distance. Similarly, if you consider this point here, it is close to the Earth here. Therefore, this point here, the point which is longest distance from the Earth, it is called as the apogee. Similarly, the lowest distance, suppose this is the lowest distance now from the earth here, that is called as the perigee. Therefore, the distance from the satellite to the earth, the longest distance represents the apogee and the lowest distance represents the perigee. In case of the circular, the distance will be same because in the circular fashion, every time it is the same everywhere. But in case of the elliptical, we will get the different distances there. Now the side real pointers. What is the side real point here? Side real point is nothing but the particular the time taken by the satellite to complete one orbit, that is to complete one complete revolution, to circle, to complete that revolution is called as the side real period here. That is, if you consider here, this is the earth again. Suppose the satellite is here and it is rotating to complete one circle full. Again, it has to come to this point only. Then that is called the time taken by the satellite to complete one complete revolution. This is called as the time real, side real period here. That time period is called as the side real period. Now the angle of the inclination. What is the angle of the inclination? If you observe here, this is the equatorial plane. Here, this is the equatorial plane, means which is drawn at the equatorial of the earth here. This is the equatorial line, means what? Which is dividing the earth into two equal hemispheres. The lines drawn from the north to east latitude lines here. Now this is the equatorial line and this plane represents the equatorial plane here. Now this is the plane of the satellite revolution where the satellite is rotating. This is the plane here. Now the angle between these two planes, the angle between the equatorial plane and the plane of the satellite orbit, this is called as the angle of inclination. Here also you can see this purple color represents the equatorial plane and this white color represents the angle of the orbit here. That is plane of the orbit. Therefore, the angle between these two planes represents the angle of inclination. It is defined as the angle between the equatorial plane and the plane described by the satellite orbit. Now 0-degree inclination are called the equatorial and orbits with 90-degree inclination are called as the polar orbits, because 0-degree means it is the equatorial orbit here and 90-degree means those are the polar orbits. Next is the angle of elevation. What is the angle of elevation? It is nothing but the angle between the line drawn from the satellite to the earth station antenna. This is the line which is joining from the satellite to the earth station antenna and the tangent drawn to the earth surface. This is the tangent here. Now the angle between these two lines is called as the angle of elevation. Therefore, how we can define the angle? Here you can see the satellite and this is the earth station antenna. One line is drawn and one more line is the tangent which is drawn to the earth surface here. Now the angle between those two represents the angle of elevation. That is, it is defined as the angle between the line joining the earth station's antenna to the satellite and the tangent drawn to the earth. That particular angle is called as the angle of the this one, elevation. Now the satellite repeater. What is the satellite repeater? For example, in case of the communication, if the earth stations are transmitter and the receiving stations are out of line of sight distance, then what will happen? They cannot communicate directly. Now in that case, from one earth station, the signals are radiated towards the satellite. Again, those are radiated towards the other station, receiving station. Now this satellite is acting as the repeater here. Now this is the uplink frequency, because the signals which are radiated from the earth station towards the satellite is called as the uplink frequency, and the signal which is radiated from the satellite towards the earth station is called as the downlink frequency. Usually uplink frequency they will take it as 6 gigahertz and downlink frequency they will take it as 4 gigahertz. Now here, from here the signal is radiated, here that is amplified. Again frequency conversion takes place here in the repeater station or the satellite. Again it is re-radiated towards the receiving station. This is acting as the repeater station. This satellite is acting as the repeater station here. Now this completes the introduction to the satellite fundamentals, some of the definitions here. In the next class, we will learn about the different types of the orbits here, that is the low Earth orbit, medium Earth orbit, and the geosynchronous Earth orbit, and the some of the comparison between those orbits. Thank you for watching. Thank you.